Welcome to AP Calculus AB video for Skill 129. I can find the slopes of secant lines and estimate the slope of tangent lines within context. As you know, the unit we are in is the column unit, and the trivia question for the day is, what other word can you think of that ends with the letters UMN? We'll begin our notes on page 129A, where we introduce the definition of a secant line. A secant line can be described as the line connecting 2 points on a function's graph. So what we have is we have this point on the graph and we have this point, and the secant line connects those 2 points. And in calculus, we start by exploring secant lines, and eventually we look at the tangent line, so the line that just touches the graph at one point. For now, we're looking at secant lines, and we can find the slope of the secant line by finding the y-coordinate of our first point and subtracting the y-coordinate of our second point. Or more easily, you could just say f of x2 minus f of x1 and divide that by x2 over x1. So really what we're doing is our changes in our y's divided by our changes in x. Incidentally, this is what we've always known to be our slope formula. I mean, we are talking about a line after all. So the slope between 2 points is going to be the slope of that line. Okay, let's use this in example 1. Find the slope of the secant line for f of x equals x to the third minus 9x from x equals 2 to x equals 4. So this graph looks something like that. And we want to find the slope from 2 to 4. So 2 is located maybe right around here on the graph, 4 is up here, and we want to find the slope between those 2 points, the slope of our secant line. So we evaluate f of 4, and we find it to be that. We evaluate f of 2, and we find it to be that. And then we divide that by 4 minus 2, getting us a final answer of 19. So the slope at this secant line is rise 19, run 1. Alright, since we're looking to extend this to tangent lines, what I'm going to have us do is, in example 2, we're going to find the slope from 2 to 2.5, and then we'll find the slope 2 to 2.1, and we'll do 2 to 2.01, and essentially get closer and closer so that we could estimate what is the slope exactly at 2. And we're going to use the function 5x squared minus 1, and we want to find the slope first from 2 to 2.5, which means we find the function at 2.5 minus the function at 2, and then we divide that by 2.5 minus 2. And that gives us an answer of 22.5. If we make the window even smaller, from 2 to 2.1, we use the same equation, and it spits out an answer of 20.5. Moving along, we get a even smaller window, and that gives us an answer even closer to 20. In the final one, we had a very tight window from 2 to 2.001, and that approached 20.005. And I suspect if we started continuing our pattern, we'd find that if we went from 2 to 2.0001, we'd get an answer of 20.0005, and that pattern would continue. So it would appear as though we are approaching a tangent slope of 20 for this function. And in fact, later on, we will learn how to prove that it is exactly 20. So our secant line approximation that we did all along here, we used to estimate the value of 20. and we're not too far away from proving that the value actually is 20. In the final example, we're finding the slope of the secant line from a table, and the context is the price of a stock drops over a 10-week period, as shown in the table. Now, I didn't actually go out 10 weeks in the table, but all we need to do is find the average rate of change from week 2 to week 3. Average rate of change is another way of saying the slope of the secant line. So what we're going to do is we're going to do C of 3 minus C of 2 all over 3 minus 2. So that's y2 minus y1 over x2 minus x1. And we find that the average rate of change is negative 8.83, which within the context of the problem means we're losing $8.83 per week on this particular stock. The problem continues and says, find the average rate of change from week 3 to week 4. So this time we are doing, let's put a black box around that. This time we're doing week 3 to week 4, so we're interested in these values. And we're going to do y2 minus y1 over x2 minus x1. And we plug those in, and it gives us a value of negative 7.81. So we are now losing $7.81 a week. Not quite as bad as the last week, but it's still losing money. Finally, the last question says, use these calculations to estimate the instantaneous rate of change for week 3. So we've shown that it's dropping over time, and we're going to look at exactly week 3 and find out what is the rate at which it's dropping for week 3. And we can do that by taking the average of these two values. Since this is from week 2 to 3 and this is week 3 to 4, they make a good way of averaging the dropping rate for week 3. So we'll just take those two values and average them, and we find that the average of the two of them is 8.32. So on week 3 we're losing on average 8.32 per week. That's our instantaneous rate of change at week 3, estimated from the table. Alright, thanks for watching the video. At the end of this, you should be able to find the slopes of secant lines either given a function or given a table which represents a function. And the trivia question was, what word could you think of that other than column that ends with the letters UMN? Here's a hint for you. That's right. The word is autumn. Congratulations for those who got it.